Hi guys. So today we're going to talk about something that's maybe a little bit odd for you guys to think about, um, but I think it's important. I'm not going to put this in one of the programming assignments, but I think it's really important for you to know. You're going to have to deal with these a lot. It's just the programming model for Python, and that's exceptions. So an exception is an error that happens when your program is running, and this happens all the time. For example, let's say you try to open a file and the file doesn't exist, or you make some other sort of error in your program, or it's not necessarily an error in every case. It can sometimes just be um, some unexpected result. Now, there's two different ways you could deal with this. One is you can just crash, right? The program can just crash. The file name doesn't exist. Program crashes. It's probably not what you want to happen a lot of times. For example, in Word, like if you try to open a file that doesn't exist, Word doesn't crash. That's kind of be kind of unfortunate if that was the way that it worked. Um, so what we can do with exceptions is we can actually put in code that will let us handle error conditions or unexpected conditions that throw exceptions. We say throwing exceptions. Um, so a traceback is an error message that gives information regarding the line numbers that call the exception. So if you've written some Python code, which you all have, and you had an error in your code, you've seen this in the IDE. It's the red text that spams up when you make a mistake. It indicates what's wrong, what happened, what kind of error happened, what line did it happen on. It basically tells you about the error that caused the exception. So that behavior that you see where um, the text spams up in the thing and your program crashes, that's what happens if you don't handle exceptions. We say handling the exceptions. So if you don't handle exceptions, your program's just going to crash. So, um, so for some examples, you can just fix these things. For example, input validation. We just have some sort of decision construct to make sure our input's valid. Some things can't be avoided with careful coding. Like for example, trying to open a file or trying to read from a file that doesn't exist, or let's say you say enter your age and someone puts CF. That's an unexpected condition. It really can't be avoided. You try to convert that to integer because you're going to add things to it. It doesn't work. Um, but what we can do is we can handle these things a lot more gracefully, and a lot of times we can recover from things like the file doesn't open. For example, if a file doesn't exist, we could just print an error and say, hey, the file doesn't exist. Um, please enter another name, or please check the name, or we can say, oh, age must be an integer. Please give us an integer. So a lot of times we can handle these problems with our exceptions if we can handle the exceptions. Excuse me. So then, an exception handler is code that responds when exceptions are raised and prevents the program from crashing. So in Java, if you're a Java programmer, there's these try-catch blocks. In C++, it's try-catch blocks. In Python, they're called these try-except statements. So the format for this is try colon and then the things that you're going to do. For example, I'm going to open a file. I'm going to say try something 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 something. Try to open my file and then try to do something with the file, and then except, and then the name of the exception that I'm going to catch, and then the things that I'm going to do if that exception happens. So let's say I try to open a file, try, file1 equals open blah blah blah, except, and then the exception name is, file not found or whatever exception I want to handle, and then the statements that I want to do when that exception happens. A lot of times code in Python is written for you to do this. Like, you must do this. It's just, it doesn't return, file doesn't exist. It just throws an exception. You're supposed to catch it, and you're supposed to handle it. Um, so the try suite are the statements that potentially raise the exception, and then the handler are the statements that you execute if that exception occurs. So for example, going back to the file example, you would want to do something like print an error statement, and then maybe then go back up to the top. Maybe it'd be in a loop or something. But the it's expected in a lot of cases, and it's best practices, if you try to execute a statement or a function that can throw an exception, then you must write an exception handler to go with it. You cannot not, because that's going to mean your program's going to crash. You always should write an exception handler for things that, again, I'm not going to test this, but if you're going out and you're writing code in Python professionally or even quasi seriously, you need to use exceptions and you need to catch the exceptions in the exception handlers. Um, so if we try to execute and there's an exception, um, if the exception is one that's specified in the except clause, then it's going to execute the statements in the except clause. And the reason that we do this is it lets us actually have a little more fine-grained control over what happens. For example, file errors versus, disk doesn't exist errors or invalid path name errors. We can catch different types of exceptions. If we don't catch the type of exception that was thrown, then we're gonna crash, and we're just gonna print out the traceback error message. So if no exception is raised, in other words, if there's no error that occurs, then the handler code is just skipped. So handler code only happens if errors happen, and it's basically code for handling errors. All right. So a lot of times things will handle more than one. Things will throw more than one type of exception. So we have to write an except clause for each type of exception. So if we write an except clause and we don't list the specific exception, it'll handle any type of exception in the try suite. So this is sort of like the default stage. So if the first one is the first type of error, the second one is the second type of exception or error, the third one is the third type, and then the last one is like the catch-all for everything. So we can have multiple types of exceptions that we can handle inside of our. So we'd have one try, and we'd have multiple except clauses. So one of the things that we want to do sometimes is we want to print out the error messages, which is what prints out when the handler prints. But maybe we want to log that somewhere. Maybe we want our program to crash. We want to save that off to a log file somewhere. So an object is created when you have an exception, which is when your exception is thrown. So we can have a variable. The way we can actually access this object by adding a variable as in our except clause. So let's say, here's an example. We have the except value error. So this is the exception type as error, and this is the variable name that we're going to have. So we can then print this error, and it'll print the error message that's part of the error. We can do other things with the error, but this will print the error message from the error. And the syntax for that is except value error as, and then the variable name. So this is the type of the exception we're going to catch, and this is the variable name that we're going to use for it. So the try-excepting statement can include an else clause, which appears after all the other except clauses. It's very similar to the else clause and if statement, but it only executes if there were no exceptions raised. So if there was an exception raised, then the else suite is skipped. So let's say, for example, let's go back to our file opening, and we catch the file open error. The else clause might be reading from the file, because we're only going to read from the file if the else clause, if the exception was not thrown, meaning we could open the file with no problems, there were no exceptions thrown, there were no errors. The else clause would be we're going to read from the file, because you're not going to read from the file if there was any error on the open, right? So the else clause only happens if all of the exception blocks are skipped, there are no exceptions thrown, and there's no errors. Then we'll do the else clause. So the finally clause is the last one we're going to talk about. So this appears after all of the except clauses. So the finally suite will execute whether the exception occurs or not, and the goal of this is to perform cleanup after exiting. So the finally will happen no matter what happens. The finally is going to happen whether it executes or not, or whether there's an exception or not. The finally block is gonna happen. How to use this, I think, is probably a little beyond this class, but it's basically the goal is for you to be able to perform cleanup before you exit. Alright, so what if an exception is not handled? There's two ways for exception to go unhandled. One, we can have there's no except clause for the type, and we don't have a default, in which case we're not going to handle it. The second thing is that it happens outside of a try suite. In both cases, the exception will cause the program to halt. Python doc has all the information about all the different exceptions. Generally speaking, if a library function or a function that you're using throws an exception, you should have an except clause to handle that exception, right? You should never let your program just flat out crash. You should always handle your exceptions. We're not going to do this in any of the programs that we're doing because it's actually outside the scope of this class. But exceptions are very useful. They are often used in Python code, and in some cases, they're the only way that a function will return an error back to you. Is it assumes that you're catching the exceptions, and there's no other way for it to pass error codes back or anything. So you need to learn to use exceptions. All right. So thanks, guys. Again, this is sort of an optional. Video. If you watched it and you got to the end, great. I think you'll be rewarded because you're going to be, if you're a Python programmer, you're going to use a lot of exceptions. If you didn't, then you didn't hear this message.